Forget any intimidating math class you've ever sat through. Today, we're not doing a lesson. We are cracking a code that unlocks the secrets hidden inside every single right triangle. And trust me, these are the same secrets used to build our cities and even design the video games we play.
You've probably heard someone mutter this before, right? So ka toa. It sounds kind of like a secret chant. And in a way, it is. It's a memory key, a little trick passed down to help solve one of the most common puzzles in geometry. And by the time we're done here, you're going to be totally fluent in it.
So why is this one little phrase such a big deal? Because it's the master key to finding any missing side or any missing angle of a right triangle. It is so powerful, so efficient, and it's about time we pulled back the curtain to see how it really works.
All right, before we can decode anything, we need to get to know the landscape. And this is our main character, the right triangle. See that little box in the corner? That's our 90-degree angle. It's the whole foundation of our puzzle. And that other symbol, theta, that just represents whatever angle we're focusing on. The entire code revolves around that angle.
So, every right triangle has 3 sides, but in trig, they get special names. First up, the easiest one to spot, the hypotenuse. It's the long one, the superstar of the triangle, and it's always directly opposite that 90-degree angle. You can't miss it.
Next, we've got the opposite side. Now this one's a bit of a shapeshifter, because its identity depends completely on which angle we're looking from, our theta. The opposite side is just the one that's directly across the triangle from that angle. Simple as that.
And that leaves us with the adjacent side. Adjacent is just a fancy word for next to. This is the side right beside our angle theta that isn't the hypotenuse. And that's it. That's our whole cast of characters: hypotenuse, opposite, and adjacent.
Okay, so we know the players. Now it's time to learn the rules of the game. Let's finally break down what SOH-TOA actually means. This is where the magic happens.
Let's start with SO. The S stands for sine, the O is for opposite, and the H is for hypotenuse. So what this means is that the sine of an angle is just the length of the opposite side divided by the length of the hypotenuse. That's all it is, a simple ratio.
Next up is CAH, and you can probably guess where this is going. C is for cosine, A is for adjacent, and H is for hypotenuse. So the cosine of our angle is the length of the adjacent side divided by the length of the hypotenuse. See, just another easy ratio.
And to complete our trio, we have TOA. T stands for tangent, O for opposite, and A for adjacent. The tangent of our angle is simply the opposite side divided by the adjacent side. And there you have it. That's the whole secret code. SO, CA, TOA. Sine, cosine, and tangent.
Now those 3 are the big ones, but they do have 3 other siblings, the reciprocal functions. Don't worry about the fancy names for now. All you need to know is they are literally just our first 3 functions flipped upside down. This table here gives you the whole toolkit for any problem you might face.
Okay, knowing the code is one thing, but using it is where the fun begins. Let's get practical and see how this actually helps us find a missing side. This is where the theory becomes a really powerful tool.
Here's a simple, foolproof method. Just 4 steps. First, look at your angle and label the sides you're working with: opposite, adjacent, hypotenuse. Second, based on what you have and what you need, you pick your function. Is it a SO, a CA, or a TOA problem? Third, write it out as an equation. And fourth, solve it. Let's give it a try. All right, here's our mission. We've got a 38-degree angle. We know the side adjacent to it is 42 units long. Our job is to find the length of the side opposite it, which we're just going to call X for now. So, let's think. How do we pick our tool? Well, we need the opposite side, the O, and we have the adjacent side, the A. Which part of our code uses O and A? That's right, TOA, tangent. So we set up our equation: the tangent of 38 degrees equals opposite, which is X, over adjacent, which is 42. And now for the last step. We just solve for X. A little bit of algebra, multiply both sides by 42. You punch 42 times the tangent of 38 in your calculator, and make sure it's in degree mode, and boom, there's our answer. The missing side is about 32.8. See? The code works.
But what if you don't have the angle? What if the angle is the missing piece of the puzzle? Well, no problem at all. Trigonometry works in reverse too. Let's check out how. Okay, this is a super important difference. It's really simple. If you have an angle and you need to find a side, you use the regular functions we just learned: sine, cos, and tan.
But if you have the sides and you need to find the angle, you use their alter egos, the inverse functions. Just look for that little -1 symbol on your calculator.
Let's try one of these. This time, we know the side opposite our mystery angle is 5, and the adjacent side is 4. Our mission is to find the angle itself.
We're going to follow the exact same logic. What information do we have? We've got the opposite side and the adjacent side, O and A. That points us straight back to our good friend, TOA. So we know that the tangent of our mystery angle, theta, is equal to opposite over adjacent, or 5 divided by 4.
So how do we get data out of that tangent function? We use the inverse. We're basically asking the calculator, hey, what angle has a tangent of 5 over 4? You type in inverse tangent of 5 divided by 4, hit enter, and it tells you the answer. The missing angle is about 51.34 degrees. It really is that straightforward.
So let's quickly recap the amazing toolkit you've just built. 1. Always start by labeling your sides, O, A, and H. 2. Use SOHCAHTOA to pick the right tool for the job. 3. Use the normal functions to find a missing side. And 4. Use the inverse functions to find a missing angle. That is the core of it, right there.
And that is not an exaggeration. Seriously. With these basic ideas, any right triangle puzzle that gets thrown your way is now something you can solve. You have the key.
So, the final question is, where does this new power actually apply? Because this isn't just about triangles on a piece of paper. This is the math that builds our skyscrapers, that calculates the physics in video games, and helps planes and ships navigate the entire globe. The code is officially cracked. The only question left is, how are you going to use it?